Anybody want to start us off somewhere in 9.3? Anybody have a good one? Rachel, what do you got? Number, or someone else if you don't have one.
No, it's fine. Never mind.
Something from 9.3. We'll go back to 53 in a second. Anything? Jacob.
Oh, I was going to say 52.
So any 9.3? 11? Okay.
Yeah.
11. Is 11 good? Okay, so 11 is 3 minus 1 over t equals 2 over t squared. Like that? Okay, so there are different paths we can take, but the simple idea is we have multiple fractions that we want to either combine or get rid of, right? So we could either combine these two things, right, and then cross multiply. That was something we did before. We combined the two things and then we cross multiply. Or we could multiply everything by the same thing. And there is something we could multiply everything by that gets rid of all the fractions. What could we multiply everything by? As long as you multiply everything by the same thing, that's legal, right? So I'm just going to show you that this is what I would do. If you multiply this out, what's 3 times t squared? Oh, 3t squared. What's 1 over t times t squared? It's just t, 1t exactly, equals what? 2. Because the t squareds cancel. That right there would be what I would do. The other way, combining the fractions and cross multiplying, are you going to get to the exact same thing?
Oh, yeah.
Yeah. You're going to get to the exact same thing. This, I find this to be the most effective in this case. So in this case, are we at a quadratic?
Yeah.
Yes. Is it in standard form?
Yeah.
What do we have to do to make it put it in standard form? Yep. So in this case, what do you? A lot of equal signs there apparently. Minus equals 0. In this case, what did I say you should always at least think to try to do? Alyssa, does this factor? Good answer. Everything is factorable, right? Is it factorable nicely? You kind of think maybe it is, like you see 2s and 3s. The challenge is that just because it looks like it's factorable doesn't mean it actually is factorable. Just because something looks like it doesn't necessarily mean it is. Is it possible? Have you gotten things that you're sure are factorable, but then you've tried to factor them and you're like, this is one of the more unpleasant experiences of my life? Yeah, I've had that same feeling. So at least try. And also, did it tell you have to use the quadratic formula on this? No. So you could just try for a second and see if it is. I mean, you know at least, okay, so the leading coefficient isn't 1. But what is the leading coefficient on this one? At least 3 is a prime number, right? At least you don't have to test a whole bunch of things. You know it's -2, so maybe like -2 and what? +1, right? Does that work?
Yeah.
That doesn't work, but what about +2 and -1? Does that work? What's 3 times t? 3t times t. 3t squared, and then what do you have? Minus what? 3t, and then plus 2t, and then minus t. Does it work? Oh, look at this. It does work, right? So it does factor. So because we now know it was a little challenging, we had to flip it around. What do we now know is true? There's one thing equals 0 or another thing equals 0. What do we know has to be true from here? 3t plus 2 equals, or, yeah, please take a second and always write that out. It's really easy to make simple mistakes on these. So 3t equals -2, t equals -2/3, t equals 1. So in this case, was this nicely factorable? Yeah, it could be a little easier. That being said, could we have done this with the quadratic formula? Theoretically, we could have, should we get the same answer? Assuming we've done everything correctly. From here, if we wanted to eject from right here, and just use the quadratic formula, can you tell me what a is going to be equal to? 3, b is equal to -1, and c is equal to? So what do you find first? Discriminant. Yeah, good job. Excellent. b squared minus 4ac. So that's going to be -1 squared minus what? 4 times 3 times -2. So that's equal to what? 1 plus what? You can do it. 8. No, plus 24. Because it's negative and negative. Negative times negative is a what? So what do we have here? 25. Did we expect to get a nice number? We did, because when we do this, x equals -b, so it's -1, plus or minus the square root of what? 25. Well, the square root of 25 all over 2 times 3, like this. What's the square root of 25? So this is 1 plus or minus 5 over 6. So how many answers is that? 2. 1 plus 5 over 6, or 1 minus 5 over 6. 6 over 6, that's equal to 1. And this is going to be -4 over 6, which is equal to negative. So did we get the same answer? Absolutely. Now what's the third method that theoretically I could ask you to use? Completing the square. You have to be able to do that. Okay. So any others from 9.3 that you want to ask about? Any others from 9.3? We can go back to 53 then. 53? Okay, we'll do 53, and then we can come back again if you want to. That's fine. 9.2, number 53. It gives you this. It gives you p squared plus bp plus 25 is equal to 0. And it asks, find values of a, b, or c so that each equation will have one rational answer or solution. So in this equation right here, what's the variable in this equation? P is the variable. P is the variable. Depending on what B is, it changes the number of solutions. How many solutions can a quadratic equation have? How many can it have? It could have 2 real solutions. What else could it have? You have 2 imaginary solutions, right? If the number underneath the radical, the discriminant is negative. Or it could have how many solutions? It could have 1 real solution. And there were 3 different cases, if you looked it up. It has to do with the discriminant. What was the discriminant? It's technically not considered the square root. The discriminant is just what's underneath it. So just b squared minus 4ac. So there are 3 cases. And I'll give you, and it's up here, sorry, b squared minus 4ac. When b squared equals 4ac is 0, you have plus or minus 0. Are you changing anything when it's plus or minus 0? No, so which one is that? That is 1 real solution. If you wanted imaginary solutions, b squared minus 4ac had to be what? Has to be what in relation to 0? If you want it to be an imaginary number. How do you get imaginary numbers? Negative. So less than 0, exactly. So if the discriminant is less than 0, it's imaginary. So what do you think the top one is? Yeah, if it's greater than 0, you have 2 real solutions, like plus or minus 5, the last one, right? So this one's asking 1 rational solution, so it has to do with the discriminant. So if we want 1 rational solution, what do we want the discriminant to be?
0.
We want b squared minus 4ac to be what? 0. Do we know what a, b, and c are in this case? In this case, what's a in this one right here? What's a?
1.
A is 1. What's b? B, and what's c? 25. So what do you do with those 3 numbers? You plug them in. So b is just b, so we have b squared minus 4. What's a? 1. And what's c? Equals, let's solve this. B squared minus what? You can do it. 100 equals what? So b squared is equal to 100. So what is b equal to? That's half of the answer. It's half of it. Plus or minus 10, exactly. So there are 2 possible answers. If b is 10, this has 1 solution. And if b is negative 10, it has 1 solution. Either one will result in 1 solution. Because if b is plus or minus 10, what is the discriminant? 0. And if the discriminant is 0, how many solutions does the quadratic have? 1 real. You'll notice you kind of want there to be 1 imaginary solution, right? Is there a way to have 1 imaginary? Nope. Actually, there is not. So I want to try one more of these just so you can kind of get it into your head a little bit. Let's say I gave you another one. It's pretty similar. Let's say I gave you this one right here, and I said the same thing. At squared plus 24t plus 16 is equal to 0. And I said I want 1 real solution. 1 real solution. What's the variable in this quadratic? No. T is the variable. T is the variable, see, because it's squared in there twice. A is just the coefficient. So you're solving for A. So I'm asking you this question. Find me A so that you have 1 real solution. See if you can do that for me right now. A is just A. What's not B? A is just A. What's the B value? B is 24 and C is exactly. So when you do the discriminant, you're going to end up with 24 minus 4 times A times what? And what do we want that to be equal to? 0. So you have to do some multiplication. You do. What's 24 squared?
576.
So can I want to give you a shorter way of doing this. So you can do it. You can write this out, but you could multiply it out. But you could also realize that what is 24? 24 is what times what? It's 4 squared times what? And you have 4 times A times what's 16? 4 times what? Equals 0. What could you divide everything by? 4. You could go by 4 and 4 again, right? So what you can do, you can cross this out, and you can also cross out, because what's 0 divided by 16? 0, right? So what does this become? 6 squared minus 4a is equal to what? 0. I'm just showing you a quicker way to simplify this. When you have 0 on the other side, can you divide everything really nicely? Yeah. Just have common things here. So what do you end up with? 36 is equal to 4a, so a is equal to 36 over 4, so a is equal to what? 9. Could you have multiplied this out and get the same answer?
Yeah.
Sure. I'm just telling you what I see, so maybe you can start doing some of the same things. Okay, any last question? We can multiply by t plus 2 squared. If we do that, we end up with what? 3 times t plus 2 squared plus equals what? What happens when you multiply 1 over t plus 2 times t plus 2 squared? What happens when you multiply this by that? What do you end up with?
1 over t plus 2.
You just end up with t plus 2 because you get t plus 2 squared over t plus 2. One of them cancels. And then what's the next one become? Plus what?
2.
Just plus 2. Yeah. Just becomes plus 2. Let's pause for a second and ask ourselves, do you understand what just happened there? It's really important. Yep. I like it this way. It's kind of clean. This communicates this. If you did this on your sheet, I would know exactly what you're doing.
Wait, can you just kind of go over the t plus how you got the 3 and the t plus 2?
Well, I multiplied everything out. I did this times this, right? That's where this one comes from, right?
Wait, what's the initial problem?
The initial problem is this. Solve this equation right there. So then I multiplied, the next one I multiplied was this times this, and which one's that? That's this one right here. Because one of the t plus 2's cancel.
Yeah.
Like x squared over x is x. T plus 2 squared over t plus 2 is t plus 2. And then the last one is this one right here. There's a t plus 2 squared in the denominator, so it cancels completely, leaving you with just what? 2. So at this point, is this a quadratic? Yes. Is it in standard form?
No.
No. One word for what we have to do next. Yeah. You have 3 times t squared plus 2t plus 2t plus 4. Do you notice, you see that parenthesis I put there? Just make sure you put it there because that 3 is multiplying by everything next to it. Everything. Katie, I just multiplied this out. Yeah. And then t plus 2 plus 2. Yeah. So now what do I have to distribute on the left?
3.
The 3, exactly. So what do you end up with? 3t squared. You have 4 t's times 3. So how many do you have? 12t plus 12 equals t plus 4. Again, we have a quadratic that's closer to what we want, but is it in standard form? No. So what does this become? 3t squared plus how many t's? 11t plus what? 8 equals 0. Now at this point, is that in standard form? Sure. Could you just use the quadratic formula? You could, but what should you check first? Factor it. What's nice is that yes. Well, what's not nice is, yeah, okay. The leading coefficient isn't 1, but what is the leading coefficient? 3, which prime, so we should at least try this. The next two numbers have to multiply together to get 8, right? So what do you want to try? What are some pairs for, what are 4 and 2? So how about, which one do you want to put where? Do you want to put plus 2 first or plus 4 first? Plus 4 and plus what?
Actually, no.
That doesn't really work, right?
The other way around.
So let's try it the other way around. That doesn't work either. So if 4 and 2, what's the only other pair that works? 8 and 1. Which one do you want to put first, 8 or 1?
8.
If you put 8 first, it will indeed work. If you put it the other way, you get 3t times 8, and that's too big. So if you do this, let's just check. 3t times t, 3t squared, plus 3t, plus 8t, plus 8. Is that what we want it to be? Yeah. So at this point, what does this tell us? The zero product property tells us that 3t plus 8 has to equal what? 0 or what? So we end up with 3t equals negative 8. So what does t equal? Yep, or t equals? Yeah, you have two answers right there. Now, theoretically, what should you do at the end of any of these problems if you have time? Do you really want to check this? Not so much, because you go back up here and you're like, yeah, I'm good. Only check if you have time, okay? Or if I say you must check as part of your answer. Do you understand? It's tough because especially because did you use a calculator to do this? No. Does this look very fun to check without a calculator? No, not really. It's not impossible, but do you really want to spend that time? Not at the moment. Go ahead. There you go. There's the whole track right there.
Oh,
Change
you
it-
made like you changed the x to k and you said
Yeah,
k
exactly.
equals x squared.
Exactly. This is actually, I call this a fake quadratic. That's my term. It's not what the book calls it. Because it really behaves like a quadratic. It just adds in one layer. If k is equal to x squared, or any letter you want it to be, what does this become? Well, it becomes minus 13k plus 36 equals 0. What does the first term become? K squared. Exactly. Well, what is this? This is just a nice quadratic in standard form. And is actually, can that be factored?
Yeah.
Yeah, it's k minus 4 times k minus 9. So what does k equal? 4, or k equals what? 9. But what is k?
X squared.
Exactly. So x squared is equal to 4, or x squared is equal to? So, plus or minus 2, or plus or minus 3. There are actually 4 answers to this. Plus or minus 2, or plus or minus 4. Oh, sorry, plus or minus 2, or plus or minus 3. It's kind of cool. I like it. What this looks like when you graph it, fourth degree polynomials look like this. So how many times can that cross the x-axis? No. 1, 2, 3, 4. We actually know it does because this is going to be negative 3, that would be negative 2, that would be 2, and that would be 3. We know it crosses at those 4 places. The specifics of curvature and how steep it is, that's not something we look at in this class, but you look at it later. But the idea is that's why there are 4 answers. It crosses 4 times. Kind of cool. So can these look a little different and still require the same work? Absolutely. So for example, this one right here, 4x to the 4th plus 1 is equal to 5x squared. Try that one for me. Sure, we like k. So k equals x squared. So what do we end up with? 4k what? Plus 1 is equal to 5k. So 4k squared minus 5k plus 1 is equal to what?
0.
That's in standard form. That's a quadratic. You should ask yourself, is this,
Factor.
and is it?
Yes.
What does it factor into, Katie?
4k minus 1 and then k minus 1.
Exactly. Good job. Perfect. There it is. So what do you know? You now know, stop it. 4k minus 1 is equal to 0, or k minus 1 is equal to 0. So 4k is equal to what?
1.
So k is equal to 1/4, or k is equal to, are we done? Because what did we say up here? Correct. So what do we have here? X squared is equal to 1/4. X squared is equal to 1. On this side, x is therefore equal to what? Plus or minus 1. And on this side, careful, what is this equal to? Plus or minus a half. Yeah, exactly. Because what's a half times a half? A quarter. So when you square root something less than 1 between 0 and 1, it actually gets bigger. The square root of a quarter is a half. The square root of a half is bigger. It's 1 over root 2. It's just bigger. It's not nice. Does this one decently make sense?
Yeah.
What? No, we just chose it to begin with, I think, because the first person I asked was Katie, and Katie's like my favorite letter is K, I think. But you could use M. It doesn't matter.
I just didn't know if there was like a.
No. Just don't use the same variable. Don't make it like x equals x squared.
Yeah, that's the hardest part for me is like I like using x a lot.
Don't use x again. Okay. What about this one? Hold on. Because this power is half of that power. Doesn't matter what they are. It could be 3 and 6. It could be 10 and 20. They're going to be fake what? Fake quadratics. So in this case, what do we want to say k is equal to?
1/3.
K equals x to the 1/3. So what do we have? 2k minus 11k plus 12 is equal to? And at this point, we try to what? We try to factor. We know it has to be both negative. They both have to be negative. So maybe minus
3 minus 4.
minus 3 and minus what? And that does work. Good job. So we know 2k minus 3 is equal to 0, or what? K minus 4 is equal to 0. So 2k is equal to 3. So k is equal to 3 over 2, or k is equal to 4. But what is k? X to the...
1/3.
And you're like, oh man, my head is short-circuited, but it's actually not that bad because you remember clearly, what does 1/3 power mean? It's not square root, it's
Cube root.
cube root, the cube root of x, right? How do you get rid of a cube root? You raise it to the 3rd power. So what is x going to be here? 3 over 2 to the what power? 3. X equals 4 to the 3rd. So it's x equals what? Nah. 27 over 8, or x is equal to 64. Boom. Same amount of work. So what's the long way of doing this one? Can someone tell me what the long way would be to do this one? Distribute it out. It's not that bad because it is a quadratic. Is there a faster way? Yeah. The faster way is going to be to say, okay, instead k is equal to what? 4x minus 3. And then you get 2k squared plus 7k plus 5 is equal to, does that factor? Well, we hope it is. K what? We get 5 plus 1 and plus 2. Does that work? I think it works, right? Because you get 5. 5. What am I doing here? 5. Yeah, Kelly's like, what? Yeah. So at this point, what do we know? 2k plus 5 is equal to what? Or k plus 1 is equal to 0. So what do we know? 2k is equal to negative 5. K is equal to what? Negative 2. Or k is equal to negative 1. But what is k? Yeah, exactly. Or right there, sorry. So what do you have? 4x minus 3? 4x minus 3 is equal to negative 5 over 2. 4x minus 3 is equal to negative 1. You have to do a little more math? Yeah, it's not that bad, right? 3 minus 5 over 2. What do you get here? 4x is equal to 2, because you're adding 3 to both sides. So on this side, what does x equal? 1/2. And over here, you have to clean this up. How many halves are in 3?
6.
Yeah, so you have 4x equals 1/2 right there. Because that's 6 halves minus 5 halves, you get 1/2. So x is equal to 1 what? 1/8. So we ended up with 2 answers here. Is it possible that both work? Yes. The challenge is finding kind of the quickest way. And theoretically, could you multiply this out first? Yes. It actually doesn't change much. It actually doesn't change much.